two problems just to illustrate how this can be used to generate a trajectory. So here's example one. Okay, find a time-based parameterization for a revolute joint of a manipulator. The joint should move from 0 to zero point 0.5 radians. So let's write it down, 0 to 0 0.5 radians from time t equals 0 to, so let's just write it this way, from time 0 to 1, followed by, so 0 to 1, followed by movement from 0.5 to 1, from 1 to 3 seconds. So 0 0.5 to 1, and time goes from 1 to 3. Okay, so you see this is not just end to end, but it goes from one point to another point, and then from another point, 0.5 to 1. There are some more conditions which are specified. These are velocity of the joint, the start of motion, uh, and end of motion should be 0. So starts end at 0, and velocity of the joint at the intermediate point. So at this point, uh, sorry, at this point should be 0.2. Okay, so a bunch of things, but let's just try to write down uh, conditions. And once you have the conditions, we can ask ourselves, what are the equations we need to write? So we need a profile which will follow all these conditions. So here are what is told to us. At time t equals 0, let's call the variable to be, let's just use q. Q equals, so at 0, sorry, at 0, time t equals 0, q equals 0. At time t equals 1 here, q equals 0 0.5. Okay, so there's 0, 1, and then 3. And then what we want here is we want to fit a curve here, and then fit a curve like this, and then another curve like that. So let's just call this one, let's call that q1, and let's call this q2. So q1 is 0, q1 at t equals 0 is 0, and 0.5 at, okay, we got that. Now let's see what other conditions are specified. Also, the velocity of the joint at the start of motion is 0. So at t equals 0, q1 dot equals 0. We are also told that the velocity point t equals 1 should be 0 0.2. So at t equals 1, the velocity is equal to 2. I think those are all the conditions which are specified for q1. For q2, note that q2 starts at 1, ends at 3. So at t equals 1, q2 should be equal to the same as q1 at t equals 1, so it will be 0 0.5. At t equals 3, q3 should be equal to, I think it's going as 1 radian. We're not done yet. We still have to specify, well, told something about the velocities. So velocity at end of motion, t equals 3, 0. And then we also told something about the intermediate velocity, 0 0.2. So that is at time t equals 1. So at time t equals 1, q3 dot, so this should be q3 dot 0. And then this should be q2, my bad. There's no q3. Okay, q2 dot is 0, and q2 dot at time t equals 1, intermediate point is 0 0.2. Did I? Oh, this is a mistake here. This should be 0 0.2, not 2. So this is basically ensuring continuity. We see this point and this one to ensure that those two things at this intermediate points have continuous velocity. And then if you look at t equals 1, so here t equals 1, this is right here, the position is 0.5, but should be the same position over here. So these are just continuity conditions. Okay, so let's just count the number of equations. We have four conditions for Q1, and then four conditions for Q2. So in general, we have 8 conditions. Okay, but we need to write an equation for Q1 and a separate equation for Q2. So what we'll do is we'll assume that Q1, we'll write essentially a third order equation, so 4 constants for Q1, and do the same thing for Q2. Okay, so let's say Q1 will be of this form. Let's call it A10 plus A11t plus A12t squared plus A13t cubed. So you can see I actually have 4 unknowns so that I can compute them using those 4 conditions. And then Q2 we'll write as A20 plus A21t plus A22t squared plus A3t cubed. So those are the other 4. Yeah, so what we would need in order to compute those constants, well, we would need to sub in the values at the distant time. We also need to compute the values at, well, we need also the derivatives, otherwise we can't ensure some of the conditions are satisfied. So we can just write the derivative right here. So the derivative of Q1 with respect to time is A11 plus 2A12t plus 3A13t square, and the derivative of Q2 is A21 plus twice A22t plus 3i's A23t square. So we'll extensively use this one and this one. Okay, just a matter of writing those equations down. Let's just start writing them for those 8 things. So let's see. So t equals 0, Q1 equals 0. Let's write that down. I'll just write it like this, just makes it easy. So that one would give me, I just need to put everything, but so I didn't need to put t equals 0. So so if I put it in this equation, the first equation, which is right here, I get 0 equals A10. Next equation is Q1 at t equals 1 is 0.5. So Q1 at 0.5 is equal to, so t equals 1 equals 0.5, my bad. So we have 0.5 equals, I just put t equals 1 in this expression. So that will give me A10 plus A11 plus A12 plus third, we now look at the velocity equation. So in the velocity equation, we need to put uh, so q1 dot. So let me write it down in this fashion first. Q1 dot as 0 is 0. So 0 equals, I need to put zeros in the second equation, this one. So that would be a11 and everything else is 0, right? So yeah. Okay. I'm just trying to write it down in such a way that all the A11s are below each other. So you'll see later on we need to pick those up and then write a big matrix. That's why I wrote it in this weird fashion. Okay, then we have the last one is Q1 dot at time t equals 1. Q1 dot at time t equals 1 is 0.2, I think. 0.2. So 0.2 equals, so I just put in the time equals 1 in this equation. So a11 plus 2, a12 plus 3, a13. Okay, so those are the four equations for Q1. Let's go to Q2. So Q2 at t equals 1 is 0.5. Q2 at t equals 1 is 0.5. So 0.5 equals, now we need to look at the second equation. So in this equation here, we need to put t equals 1. So a20 plus a21 plus a22 plus a23. Next we have Q2 at t equals 3 is 1. So 1 equals, I need to put 3 in this equation for time. Sorry, this equation, my bad. This equation I would put t equals 3. So a20 plus 3 times a21 plus 9 times a22 plus 27 times a23. Almost there. Next is Q2 dot 0 is at time t equals 3, 0. So Q2 dot at time 3 equals 0. So 0 equals, take this equation, put time t equals 3. So a21 plus 6 times a22 plus 3, 3 square 9, 27 times a23. 6 times a22 plus 27 times a23. And the last one is Q2 dot at t equals 1 is 0.2. Q2 dot at times 1 equals 0.2. So 0.2 equals, I need to take this expression and put time t equals 1. So a21 plus 3, no, 2 a22 plus 3 a23. Okay, so these are my 8 equations, 8 unknowns. Just this much space will be needed. Actually get more space. Okay, I'll collect all the constants on the over here, a10, a11, a12, a13, a20, need more space, a21, a22, a23. Over here, I would put in everything on the right hand side, on the left hand side here. All this would be on the right. So 0, 0 0.5, 0, 0 0.2, 0 0.5, 1, 0, 0 0.2. Okay, and then the last thing is I need to get these constants in front in the right place. So this is actually not very hard now, because you see that the first four equations are only related to the first four constants. So the first one will have a 1 for a10, so there's a a10 in the first. So it'll be a0, 0. So there will be 7 zeros. 3, 4, 5, 6, 7. Okay. Next one will have 1, 1, 1, 1, because there's a 1, 1, 1, 1, and then 4 zeros. Next one will be 0, 0, 0, not right, 0, 1, 0, 0, and all zeros. Next one will have 0, 1, so 1, 2, and 3, 0, 0, 0, 0. So this is part 1. I'll show like this. Makes it easy to visualize. And now whatever is going down is going to be the second set of equations. Okay, so next I have, not here, should be right here. Okay. Okay, now we have 1, 1, 1, 1, but the first four would all be 0. In fact, the first four will be 0 for the next four rows, right? So 1, 1, 1, 1. Next, we have 1, 3, 9, 27. Next, we have, so there's a 0 for a20. So 1, 0, 1, 6, 27. Then we have 0, 1, 2, 3. So effectively, we have, this is our A, this thing is B, and this unknown is, let's call that X. So we have AX equals B. And to solve for X, we need to do A inverse B, and that will give us the constants. And once we have the constants, we can find what the curves will look like. So I'm going to show you Python code, but this is what comes out. You don't want to invert this by hand. This is going to take some time. So using Python, what I got was X was 0, 0, 1.3, minus 0.8, and I'll show you the code, 0.55 minus 0.375 minus 0.4 minus 0.075, which are A10, A11, A12, A13, A20, A21, A23. And then you can obviously get the Q1, which is A10. I just not write down, but you get Q1 and Q2 from that. Okay. So what I did here was I wrote down this A matrix. Now, it might look a slightly different from the one I wrote down. So for example, if you see the one I wrote down on the notes, it will have zeros for the first four rows. The last four rows, first four columns are all zero, but they have been moved. They're different here. It turns out that the way I wrote those equations was slightly different. The order was different, which means that I actually moved this was the position constraints, all these four, and these are the velocity constraints. That's why you see that there's some zeros. But it's just a matter of rearranging the rows. You'll get the same, basically the same solution. So what I did was I wrote the A matrix slightly different by exchanging the rows. I wrote the B matrix. I computed X, which is the A inverse times B. And then I computed, when I got the A's. And then to show that what the curve would look like, I created a time variable from 0 to 1 with 101 grid points, T2 from 1 to 3. And then I basically found Q1, Q2, Q1 dot, Q1 double dot just by taking the derivative. So let's just look what this looks like. Okay, so here it looks, so position is continuous. Velocity, we said it's 0.2. So it looks continuous. Let me just put this so it will not close. Okay. Okay, so position, for example, is continuous, not surprising. Velocity wanted to be continuous, but you can see that there is like a kink here. Even though the velocity is continuous, acceleration will not be, because acceleration is the rate of change of velocity is the slope. The slope here is something negative, and the slope of the red line is positive, and you see it here. The slope, which is basically acceleration, is about -2, and then it jumps to something which is slightly above zero. It's positive. So this is not good for the motors. In fact, it's also not good over here, because you start from zero, you jump to something above 2, and then here you have to jump again, and then so this is what comes out. So it basically satisfies all the conditions we have. Let's do another problem um, where I modified some of the conditions to see what it looks like, and I will not go through this much detail as I did for this question. I'll leave apart a big chunk of it for you. Uh, so I'll set up the equations, but I'll leave it to you to solve it, and I'll give you the code which is used, and we'll look at what it looks like. So here is example 2. We have, it's based on the first one, as you'll see. So revolute joint, same as before. It moves from 0 to 0.5, from 0 to 1. That's the same as before. The next step, it moves from 0.5 to 1, from 0 to 3, 1 to 3. Exactly the same conditions as before for example 1. Now, uh, there are some changes though. Uh, this one is the same, starts with 0 speed and ends with 0 speed. So 6 conditions are the same. Okay, so what is different is the following. You've been told that the acceleration of the joint at the intermediate point should be continuous. Okay, so again we have 0, 1, and 3. We'll connect this with a curve Q1, connect the second one with a curve Q2. We need to set up the conditions. So Q1 at time t equals 0 is 0. Q1 at time t equals 1 is 0.5. Then we have Q2 at time t equals 1 is 0.5. And then Q2 at time t equals 3 is 1. That's all. Then the velocity of the joint at the start of motion is 0. So start of motion means we need to go with Q1. Start of motion is at 0. So Q1 dot is 0. And then end of motion over here, Q2 dot at time t equals 3 should be 0. So we've got 6 conditions. Now, we also have acceleration of the joint at the intermediate point at t equals 1. So if you look at this point here, we want to ensure that the acceleration is continuous. So what that condition is that q1 double dot at t equals 1, so acceleration at the end, should be the same as acceleration we obtained using q2. Okay, so we have, so those are all the conditions which have been given to us, right? So we have 7 conditions, right? 6 conditions here. And then 1 condition here. Now, one thing we notice is that if the acceleration has to be continuous, the velocity better be continuous, otherwise we'll have a real problem. So this is not given, but it's sort of obvious that the velocity also has to be continuous. So this is something which we get from what we know about acceleration. It is basically the rate of change of velocity. So that better be continuous. So that is the one other condition. So we have here 8 conditions. So we'll have 8 equations. So to generate 8 equations, 8 constants, we'll assume a same form, a10 plus a11t plus a12t square plus a1 cube. That's for q1. And for q2, we'll have a20 plus a21t plus a22t square plus a23t cube. So 8 unknowns. So 8 equations, 8 unknowns, we can solve it. 8 equations, 8 unknowns. So you got to set up the same, got to set up the equations based on the same way I've done before, and then solve for the constants. Okay, so I would say that you can do this yourself. I have given you, I'll give you the code, which, well, I did this myself, of course, and then this is what I got. Okay, so here is q dot, q double dot. You can see the position is continuous, expected. Velocity is nice, it's continuous. Okay, and then acceleration is also continuous. So the consequence is there's no kink here. You can see the slope of q dot at for the blue at t equals 1 is the same as the slope for the red dashed line at t equals 3, and so that's continuous. But here you can see that there's a kink, which means that if you look at the third derivative or the jerk, that would be discontinuous. Okay, so you could obviously specify more conditions and get more complex curves, but this is how you proceed. So this is just putting fitting sort of pushing up lines through or curves through points, and it does exactly what you want to do. And this is all is done because you want to ensure the movement of the joint is smooth, it's not discontinuous. Okay.